Those are hurtful words. Don't you hear that?
What? Saying the word shut up?
Yeah, these are hurtful words.
So we're going to refrain from using hurtful words such as shut up. All right, here we go. Exponential functions. All right, so our objectives today, we're going to graph exponential functions, and we're going to solve problems modeled by the exponential equation. There's our state standard. All right, so what's an exponential function? All right, so it's our exponent, or excuse me, our variable is in the exponent. That's what makes it an exponential function. And it's called an exponential function only if base is greater than 0. So this is your base. So it needs to be greater than 0. And b is not 1 and x is a real number. So when we graph it, we're going to make a parent function and then we're going to shift it. So let's get, just in general, let's look at an exponential function. And this time our base is 2 raised to the x power. And what we're going to do is we're going to plot some points. And I may make the table to go with it. I think that can help us. So we're going to think of x, y. And I just think the easiest one to start with is 0. What's 2 raised to the 0 power, guys? 1. So I'm going to put that right there. So go down a little bit. Okay? And then we're going to recognize that it's going to take off exponentially. So what's 2 raised to the 1? 2. And 2 squared is? 2 cubed is? 8. And we don't even have to write all those. And 2 to the 4th is 6. It's going to take off exponentially. Y'all with me? Now let's plot just those points. Let's just start with those points. So we know at 2 raised to the 0 power is 1. At 2 to the 1 power it's 2. At 2 squared it's 4. At 2 cubed it's 8. So what you can see here is, up to that point, see how our graph is growing exponentially. Okay? Now, as we go to the left of 0, we're going to see our graph is going to quickly approach 0. Okay? And we're not going to write them all down, but we're going to talk about it. So, if I plugged in -1, what's 2 raised to the -1? 1/2, right? Don't we flip? Don't we flip? So that becomes 1/2. What's 2 raised to the -2? That would be, here, I'll write it out just so you can see it. It's 2 raised to the -2, which becomes 1 over 2 squared, which obviously becomes 1/4. Okay? What would, I'm not going to write it, what would 2 raised to the -3 be? 1/8, 1/16, 1/32. It's getting smaller and smaller and approaching what? 0. It's approaching, so I'm going to grab a highlighter here, and I'm going to graph a horizontal asymptote at y equals 0. And you need to emphasize you have a horizontal asymptote. And then I'm going to come in here, and I'm going to go -1, 1/2, negative. So that's enough. I can see that I am approaching that horizontal asymptote. Ethan.
We've done this before, right?
We have done these a little bit.
Yeah.
Yes, but we have not done the exponential decay.
Okay.
And we're going to shift.
Oh.
And we're going to shift. We're reviewing this because later on this chapter, we're going to do logs. And logs are the inverse of exponential. That's why we're making sure we have this. Okay? Who remembers doing this a little bit? Okay? Good. Good. So, did we do one where it was exponential decay? Let's see. Now, our base is less than 1, which means there's going to be decay. And you're going, what do you mean? Well, this is what I'm going to do. I'm first going to come in, I'm going to put a horizontal asymptote at y equals 0, because there's been no shift. So I'm coming in, I'm putting a horizontal asymptote at y equals 0. And then I'm going to make a little xy chart. And I'm going to put 0 right here in the middle. Anything raised to the 0 power is obviously 1. So I'll put that point in, 0, 1. But when I plug in 1, what's 1/2 raised to the 1? 1/2. What's 1/2 squared? 1/4. Notice how I'm approaching the horizontal asymptote this way. And if I plugged in -1, what's 1/2 raised to the -1? That would be 2 raised to the +1, which is 2. So -1, 2. What would 1/2 raised to the -2 be then? 4. So let's plot these points. So I have -1, 2, -2, 4. If I did -3, it would be -3, 8. And you're going, and this is an exponential decay. And what I mean by decay is it's decreasing. Y'all follow me? So you should recognize right now from those two examples, when your base, what's getting raised to the exponent, is bigger than 1, it's an exponential growth. And when your base, what's getting raised to the exponent, is less than 1, it's exponential decay. Are you following me on that? Okay. All right, so now, this graph has been shifted left 2, down 3. Y'all follow me on that? Now, what I recommend for some of you to do, and I remember teaching you some of you this, is first off, did I go? I'm sorry, guys. Whoa, there we go. What I'm going to do is I'm going to make a little XY chart of the function f of x equals 3 raised to the x. And we should be able to do that real quick. So if I'm talking about this function, guys, what's 3 raised to the 0? What's 3 to the 1 power? 3. What's 3 squared? 9. What's 3 raised to the -1? 1/3. Are we okay with that? Does everybody see what I did? I went back before the shift. Now, what I'm going to do is I'm going to create the new XY chart. Okay? And you know what? Can I do one other thing? Below that XY chart, I want you to write what the horizontal asymptote is. What's the horizontal asymptote for f of x equals 3 raised to the x? It'd be y equals what? No. The original. Y equals 0. Okay. Now, from these values, let's shift. Let's shift. You follow me? So, what does this x plus 2 do? It shifts it which way? Left, how many? So this -1 is now -3. Nice. What's the 0 become then? -2. The 1 becomes -1. The 2 becomes, okay. Come back up here. What's this -3 here do? Shifts our y values down 3, yes? So this, I know the 1/3 is going to make things ugly, right? But what's 1/3 minus 3? -2 2/3. Okay. What's 1 minus 3? negative 2. What's 3 minus 3? 0. And what's 9 minus 3? And then also, the horizontal asymptote has been shifted down 3, so y equals negative 3. The very first thing I'm going to do is I'm going to graph the horizontal asymptote at y equals negative 3. Everybody cool with that? And then I'm going to plot points in my new table. Negative 3, comma, negative 2 and 2/3 is like right here. Would you agree? Negative 2, comma, negative 2. Negative 1, comma, 0. 0, comma, 6. Uh-oh, that was bad. Let me try that again. What do you guys think? We okay with that? Questions? All right. Okay, I'm going to hit pause on the record. Okay, so y'all have the new graphs on the board. So I'm going to go with the horizontal asymptote first. Is at y equals 1. Let's all graph it if you haven't already. So y equals 1. And we're going to plot our points. We're going to say negative 1, comma, 3 and a 4th. Is that right? Okay. We're going to say 0, comma, 2.5. We're going to say 1, comma, 2. And what we're seeing now is 2, comma, 1 and 2/3. 3, comma, 1 and, what is that, 4/9? We're getting closer and closer, and what we have is this going on. And just so I have that in our notes, that final table after we did our shifts was what? Negative 1 and 3 1/4? 0, 2.5, 1, comma, 2, 2, comma, 1 and 2/3, and 3, comma, what? 1 and 4/9. And our horizontal asymptote was at y equals 1. Do you guys like this, how we're doing the table and then doing the shift? I just think it's going to keep everything straightforward, especially when we go to our logs. The function equals negative 2 raised to the x. I'll do this one with you. Let's make an xy chart. What's 2 raised to the 0?
1.
And then you make it negative 1. Okay? What's 2 raised to the 1 power? And then you make it negative 2. What's 2 squared? 4, and then you make it negative 4. Let's go the other way. Negative 1. Be careful here.
1/2.
What's 2 raised to the negative 1? 1/2, and then you make it negative 1/2. So 2 raised to negative 2 would be negative 1/4. Our horizontal asymptote is still y equals 0. Let's graph that. What did this negative do out in front? It just had it reflect it over our horizontal asymptote. So as I look at the graphs, we have negative, I'll start with 0. 0, comma, negative 2, 1, sorry, should be 0, negative 1. 0 comma negative 1. How about 1 comma negative 2, 2 comma negative 4, negative 1 comma negative 1/2. So we're getting closer and closer to our horizontal asymptote, just like that. We're good on this? I haven't talked about, let me ask you real quick. What's my domain? So let's write it down one time. So our domain is what? Negative infinity to, I think I got positive x values over here, right? So from negative infinity to infinity, come on, Vance. All right, Vance, here's your chance. Redeem yourself. What's your range?
Negative infinity comma 0.
Parenthesis or bracket?
Bracket.
Why is it?
Oh wait.
I don't reach 0. I approach it, so that's why it's a parenthesis. It's okay. We good? So here's what I put together here. Just make sure we're clear on this. If b is greater than 1, our function is increasing. If b is less than 1, but it has to be greater than 0, we have a decreasing function. We kind of emphasized that, didn't we? Okay. Last thing we're going to do today, compound interest. So let's look at this. I'm going to take some money. I'm going to invest it. It's going to be compounded however many times. So K is the number of times per year interest is compounded. Okay? All right? And then we have K raised to the T power. A lot of people are confused what compound interest is. Okay? Let me ask you this. So, and I don't care to not meaning to delve into family financial situations, but I think we all can understand, and maybe we've heard of people getting themselves in trouble with credit card debt. Okay? You put something on a credit card, no interest if you pay it off at the end of the month or whenever the billing cycle ends. But if you don't pay it all off, it immediately starts compounding at a certain interest rate. And you guys know for a credit card, most of them it's not monthly. They're compounding that credit, that money that you still owe them on a daily basis. So, and here's what's really bad. Credit cards usually are like 15-20% interest. So say you owe, let's just take $500. Say you owe $500 that begins start compounding at 20%. Okay? And so then, after a day, it's 20% of 500. It becomes a new amount, right? And then they compound that amount if it's not paid the next day. And they take that new amount and they compound that at 20%. See why it's so hard to then get out of it? Because it's compounding. That's what we're seeing here. Now, some accounts compound on a monthly. Some accounts compound on a daily. Very few, other than bad interest. Y'all with me? That's why investing into certain things that are doing well, you're taking that money that you just made and it's reinvesting. And there's highs and lows of the stock market. But I will tell you, over any 10-year span, the stock market has always been higher than what it was at the 10 years before that. All right? Just not that long ago, just a month or two ago, the stock market took a dip. You know, I was looking at one of my Roth IRA accounts, and hold on, I'm going to hit pause on all this. This doesn't need to go in a video. I was